Hello. Hi guys, good morning. Welcome back. So this problem took a bit time to make the notes for because the examples given in this problem are not good to explain all the cases needed. So I have to custom made the examples like bit by bit for every case. I have to go on and make the examples. So yeah, it took a bit time and it is 12:43. So yeah, let's see what the problem says. It says that count the number of powerful integers, and again we have seen a similar kind of problems 8-9 times previously, so no worries. And the first thing which should come into our mind while reading the problem itself will be what we will be applying. Again, many people have solved it using binary search, by using simple like recursion also and all that stuff, but we know what's going to be applied because of what we have seen and what is applied in these kind of problems. It says that we have given three integers: start, finish and limit. Okay, we have a start, we have finish and we have limit. These are three integers, not strings, which makes the problems much more easier. You will see how, because integers are just, or basically numbers which are like long are just of length 20 or at max 19, 18. You are also given a zero indexed a string s representing a positive integer. So now we have string s given which represents a positive integer. A positive integer x is called a powerful if it ends with s, which means the suffix. Let's say if I have my x as 4234. So I will call this x as powerful provided it is ending with the s. Let's say string s is 34. So it should end with the string 34. Then I will call this as a powerful number. So a positive integer x is called powerful if it ends with a string s. In other words, s is the suffix of x. S is the suffix of x. Okay, and each digit of x is at most limit, and also this one more condition that each digit of x is at most limit. Limit is, let's say my limit is 5. So okay, all digits are less than 5, but what if I asked you my limit is, let's say 4? So for sure like every digit should have also been less than equal to 4, which is also right. What if it would have been a 5? Then okay, it should have been less than equal to 4, thus it is not the correct case for us, which means it is not a powerful, it is not a powerful integer. Okay, great. Now we have to return the total number of powerful integers in the range this. As soon as this range comes in, the first thing, again, it's a range given of with two integers. I have to figure out all such numbers in this range which satisfies two conditions. First condition is it should in the like every digit should be in the limit, and second condition is that every number such formed such that its suffix is actually a s. I just want to form all such x's that should be in between. Now the first part is it should be in between. So very basic thing, either we can actually start off from start to finish. Either I can go on and iterate on every digit, I can go on every number from start to finish. That is one option, but I can say with the constraints that it is 115. So for sure in the worst case I cannot go. Now in such cases we know for sure that as we have to go on from start to finish, so rather than going on the numbers, I will go on the digits. So I know that I will have 15 digits. So I will be saying, okay, what digit I can be placing here, next what I can be placing here, next what I can place here, next, and so on and so forth. This is the for sure. This is in turn when you have to figure out some numbers between a range, that is where a digit DP is being used. So you can just write on YouTube digit DP by R method. You will get many problems which we have discussed previously also. But this is an indication of that we gonna use a digit DP. But bhaiya, we also have to have these two conditions, right? So this will not be a normal digit DP. This will have a slight modification saying that okay, I will have to incorporate these two conditions. Now, if you had not known what a digit DP is, that if I ask you, you have to figure out the numbers. Now, let's forget that I have to incorporate these two conditions. Let's forget for now. But let's say if I ask you, if you have to figure out the number of numbers in this range which satisfy the condition X. Let's say condition is X. So what you will do is, you will go and solve for such numbers in the range from b to 1, and you will also go and solve for such numbers in the range of a minus 1 to 1. Let's say a to 1, such number which satisfy the condition X are, let's say, 10. A minus 1 to 1, such numbers which satisfy the condition X are, let's say, 3. So such numbers which are between a to b which satisfy the condition X will actually be 10 minus 3, which is actually 7. And that's how I can simply get my answer. And thus you can see I can use the same solve function. Now, okay, now my problem boils down to that I will have 1 to b, basically 1 to b, I will have this. Now my condition is that it should satisfy the condition X. Now X I will modify with the code itself and we'll see how it will look like, but should satisfy this condition X, and then I have to find out such numbers, such number of numbers. I will have to find this out. Now for sure, if I, let's say, name this b as a number 764, right? 764, okay, it's a 3-digit number. So I have to figure out all such numbers in this range from 1 to 764. Or I can also say, okay, 764 is this number, okay, base number is 001. So I have to try on for all the possible values, right? As you can see, all the possible values I can try, So, okay, for this first location, I can either place a 7, I can place a 6, I can place a 5, and so on and so forth. I can place a 1, I can place a 0. For the next location, I can place a 6, I can place a 5. Oh no, bhaiya. You can also place a 5. After 6, you can also place a 9. So basically, you can place from 0 to 9. Oh, now, for after 7, I can only place a 6 or a 5 or a 4 or a 3. I cannot place a 7 after this specific 7. But bhaiya, why? Because if I place a 7, then I will form a number which is 7, let's say 0, which is more than 764. But you remember that you have to bound your higher, you have to put a tight limit. Okay, my tight limit is this, so I should be making number less than this tight limit. Okay, so I will have to put a tight. So in digit DP, there is the term known as tight that says, okay, what all numbers you can place at this location. At this location, I can place my numbers from 0 to 6 because its previous number was a tight. It was a 7, which was tight, which was actually matching with the existing input. So this is my input. This is what I am trying to make right now, and I'm exactly matching with my input, which means I am very tight right now. I have to move. I have to specifically, okay, I can just assign some range of numbers to the next number. But if it is not tight, it is 6, 5, 4, 3, 1, 2, 1, 0. It's not tight. It is not equal to this number, right? It is not tight. So for sure, its later ranges is also not tight. So I can place any number from 0 to 9, 0 to 9, 0 to 9. So this is the term called as tight, right? So I can just say my tight. How my tight is used? My tight is used just to figure out the upper bound. You saw here it is, lower bound is always 0. Lower bound is always 0. Upper bound is changing. So my upper bound will depend upon tight. If my tight is actually a 1, right? If my tight is 1, or I can also write the same thing as my tight is either a 0 or 1. If my tight is 1, then my actual upper bound is my nums of I. My upper bound is my nums of I. So if I am at this index and I am saying my tight is 1, so my upper bound will be 6. But if my tight is 0, then my upper bound is a 9, simple 9. But bhaiya, okay, that is how a digit DP standardly works. But in this example, you know that no matter what, your upper bound will be bounded by a limit. which is your condition X was having two conditions. This is the suffix condition, this is a limit condition. So for sure, you know one thing, that your upper bound will be bounded by limit. So I know one thing, that my upper bound will always be bounded by a limit. So rather than 9, I will place my limit here. But bhaiya, here also you should place a limit, no? Yeah, that I will handle automatically, although you can place a limit here also, but you will have to handle, like you have to make sure the further code which you are writing, because upper bound you will be using later on the code. So how you are using that in the later part of the code, that will depend upon if you use your limit bound here also, or you can just, while using later on in the future, you can do minimum of upper bound comma limit. That is also how you can use. How I will use it like this, although you can use it with here also, no worries. Now coming on, okay, now you know that how a digit DP basically is applied. Now let's come on to making an example and figuring out how this specific suffix part condition and also this limit condition can be applied for us. So in my code, just for reference, I will use my num. As you can see that I will have a start, I will have a finish. So as you remember that, okay, my range is from start to finish, which I can bifurcate that as, okay, solve for nothing but your finish comma like something and solve for start -1 comma something, right? So I know that I can just get the string out. Okay, I know this is a string, this is an integer. I can do a minor, I see this is an integer, so I can do a -1 in the start and convert that to a string, so it will become a 14, and then convert that to a string, it will become a string of 14, and then I can just pass that string. So this is the string num which I am representing. Okay, this is the num string which can be finish or it can be a start -1. Now, okay, my actual suffix string, which is s, which is given itself, that is s itself. Now my type, initially you know that you are starting off with the 2 value, you start off with the, okay, you have this num itself, you will start off with the 2, which is for sure you will have a type in the beginning. You cannot ignore the type, so you have a type in the beginning. Now this is just to showcase that which index you have to follow. So here in place of n right now shows me the number of the basically length which I have to query right now out of this string, input string, which I have right now. So nums is my input string right now. I am saying, okay, I will just query this string of length 3, or indirectly I am saying that I will query this index. So either in place of this, see, again I will show you many possibilities how you can solve it. In place of this, you can also give the index, let's say starting from 0 itself. So okay, you will say, okay, index is 0. So this, I am only using this specific thing just to access any index. So in the beginning, I will access this 2. Next, in the next step, I know my 2 is done, I will try to access my 1. So I will simply decrease, I know this is actually of length 3, so I'll decrease, see this I will keep as constant. I'll just keep on decreasing my n to actually start accessing next element. I'll try to access 1, then in the end I'll try to access 5. So that is how I can use my I. Again, you can also use, how I will use my n. Again, also you can also modify this as to a 0, as an index, and then you can try accessing your elements as in from 0, then 1, then 2, and then so on and so forth. So it is accessing the index. Ultimately, this is what I am doing ultimately also, and also this is the input, which is the limit. Now a very base case, that at any point of time, if I say, okay, this nums which is for sure in between, which is I am using the start and finish to make this nums, right? Once my num will be finished and once my num will be start -1. Now if I am saying that if my nums value itself at any point in time, if my nums value itself, let's say it is 64, while my s value, which is a suffix value, it is 3436, or let's say 464. Now you can see my s which is a suffix, it is of length more, and my input string, which is nums, it is of lesser length, and ultimately my condition says that the s should be a suffix of my nums. It's no way possible that I can have a suffix of a lesser length. So that's never possible. So for sure, this is not even possible. So one thing is for sure that is not even possible. So that is simple a case that if your num's length is less than your s length, which is the suffix length, then simply return a 0. Now comes an interesting case that bhaiya, I will, as we showed above also, that this will be my nums and this will be my suffix. So I will have to keep on generating the numbers. That for that I will use my type. That is one thing. I'll also make sure that my numbers, basically the digits which I'm generating, should be in the limit variable which I had. And also when I am reaching the end, so I will have to make sure that my s, which is a suffix, which is the suffix string, should match with my suffix of my nums. This is I will have to make sure it should match. Basically it should match, or basically it should be able to possible, or basically I'm saying it should be able to generate my suffix, basically my end portion of my nums should be able to generate my this s suffix. So that's my conditions. So now let's see how we can solve it. So again, I made my own example to figure out all the cases which I should have make sure. Again, my code was a very messy code, so I tried that how we can club this code up and get the best solution up. But so for that you have to figure out all the cases which could be possible for it. Although it's not much, but yeah, you just have to figure out. So what I did was I took my nums as a length of 4. I took my s suffix string as a length of 2, so that I could handle both the cases. How both the cases? One case is that okay, I am at a location which is not a part of my suffix, so I can try on for multiple possibilities. Here in this starting portion, I can test out my tight thing and my limit thing. Here in this remaining portion, which means the last two portion, I know that is my suffix, so I have to match it with my suffix. So I will just make sure, okay, if I have to match it with my suffix, so I'll make sure, okay, I am using the logic that I am comparing with the suffix s string itself. Okay, so that's how I tried to make a string of length 4 and a s string of length 2. Now, okay, and I tried to modify this limit, but so basically what I did was I tried to make a string out. S, as you can see, it's still empty. I will try to make it while I'm making the answer. This nums also, I kept on making that as I was going on in the solution itself. Now I tried to test out, okay, my limit thing first, because you know a simple tight, we had already discussed that a simple tight works on this concept. As we saw above also, our simple tight will work on this concept, right? So just to verify that if our tight was working correct or not, so what I did was I took my current number as 8. My limit was 6. So as you can see, for sure, initially in the very beginning, for sure it will be tight. In the very beginning, it will be restrictive, that you cannot go at 9, 10. It will be restrictive. It will be up till 8 only. It will be 8 only. In the very beginning, you cannot go beyond 8. See, tight means, okay, you cannot go beyond this specific index value. Tight, in the beginning, it is tight. Okay, you cannot go beyond 8. And also, I am limited by limit. So for sure, you will see, okay, in the beginning, I am tight. So right now, I am limited by tight. So right now I'll say my upper bound is actually 8. So now I am saying that my upper bound, and how did you found out your number 8? So as I showed you earlier also, that I will be using my n, just saying initially in the very beginning my length of the string is actually a 3, and then rather than reducing my string, okay, one way is you use a 215 and then you just get a 15, then you get a 5. It is you are reducing your string itself. Rather than reducing my string, I will reduce my length. This, or basically I can increase my index also. I can say the same thing, and with that I can try to access those index elements. So in the very beginning, I will try to access my element 2 with the value of 3. So I know that, okay, my n is 3, my length is 3, so my length is 3 of this entire thing, and this num's length it will always remain fixed. I will just decrease my n. So that is one thing which I have to make sure. That's how I can access my nums. Again, there are multiple ways to solve it. I solved it in a different way, but I made many conditions. That's the reason I'm not showing my specific code. But yeah, logic is still underlying, exactly same. Now coming on that, okay, bhaiya, upper bound right now is 8. But for sure it will be limited by 6. So ultimately in the logic downwards, I will have to limit that by a 6. So I know that, okay, my tight is what? Tight, if it is actually a number 8. So I know if my tight is there, as I also spoke earlier, if my tight is 8 here, then I'll just communicate my tight to the next number also. So for the next digit itself, he will also be tight. If I am tight, 8, as you can see, 8 is there. If I am tight, next digit also will also be a tight. So he will also be in this range, 0 to 7. If I am relaxed, which means, as you can see, my number, if at this location I was 8, so next location I can place any number, but it should be between 0 to 7. Now if I'm saying, okay, rather than 8, I place a number 7. So next number I can place any number 0 to 9. So I can place any number 0 to 9. So that's how I can use my tight. Now coming on back, that as we saw that our upper bound right now is limited by a limit also. It is limited by a limit also. So I'll just say that my upper bound is 6. So I will have multiple values. So a few values are, again, for the first index, for this specific first location, I will have multiple values. I will have from 0 to 6, I can place number from 0 to 6, but representing that 0 to 5 are not tight, but 6 representing a tight. 0 to 5 are not tight, but 6 representing a tight. But bhaiya, 1 second. If 6 is representing a tight, and what if your number was not same, which means if this would have been a 4, okay, no worries. If this would have been a 4, I would have just said that, okay, my limit is actually a 4 itself. So that would have gone to 0 to 4, in which 4 would have been tight. Okay, great. Now as you can see, my 0 to 5 is actually tight. It is not tight. It is actually 6 is tight. So I can ultimately say that when it is not tight, it will propagate not tight to its next indexes. He will propagate tight to its next indexes. Now when I say propagate, I actually mean that I will simply pass on my function that, okay, solve reducing the length. As you saw, I was using the length n itself. So I just say, okay, reduce the length, it is not tight, and propagate that it is not tight. Here I am saying, okay, you also reduce the length, but now you have to propagate that it is tight. Okay, that's how I can simply use a tight and non-tight. Now this exact same thing logic which I also showed above, that I will try on starting from the digit 0 up till the digit less than upper bound and bounded by the limit, and then I will just simply call my solve function. My solve function is a basic function, like recursive function, as I showed earlier also. I will say if it is a tight, if that number is a tight, so simply mark that as a tight. If that is tight, which means I got a tight and also I'm matching my upper bound, then I will propagate a tight to my next person, which is actually n-1. So I'll propagate my tight. So these are the only two variables which I am having in my entire location, which is my length of my specific nums, and this length is just representing my index. So as to reach to my index, I am using this. That's it. And this is representing my type. Okay, great. So that is how I can just propagate for all the again considering I am not even bothered about the S part right now, because you saw that this portion is out of the scope of S part. S part will come in when I will have last two characters here, because you can see S part is of 2 characters length. So I will be concerned about the last 2 characters only. We will see that what we mean by last 2 characters, how to know even if we are actually reaching that location or not. But yeah, we are only concerned about the limit right now and upper bound, which is tight right now. Okay, so I know that if I'll just take the same condition example here, I know I will have a 2, then I will propagate not tight. So at this location I can place any number from 0 to 9 itself, but you know that your upper bound is limited by a limit, so you can just place an upper bound of 6. Here after 6 you are bounded by a tight, so your tight is true, you are bounded by a tight, so you can only place a number which is actually in the bounds of your this next place value. So you can see your next value was of 4. So you cannot place any value more than 4. So after 6, I can place number from 0 to 4, but after 2, I can place a number from 0 to 6 because it was not bounded. Although if this limit value would not have been there, so I could have written 0 to 9 itself, but the limit is there. So I will write 0 to 6 itself here. Okay, great. 0 to 6, I will write. So this is an example of how the tight and limit will propagate parallelly. Now coming on back, the condition when I will match with my suffix, which means now my suffix will start matching. As you can see, now I will go on again. Remember this fact, 6, 4. 6, 4, 4, again it's a tight, so you are propagating tight to the next value also. 6, 4 is a tight, so you are propagating tight to the next value also. So I'll just say, okay, 6, 3, 3 is not tight, so you will propagate a not tight value to the next value also. Okay, now let's take this 6, 4 case where you propagated your tight value. The tight is right, which means you have your tight. Now if it is tight, which means you are bounded by your existing value. Okay, bhaiya, what was your existing value? Existing value was a 5, so I am bounded by a 5. I cannot go beyond 5. Okay, because I was a tight, I cannot go beyond 5. So here, if I was a tight, so I cannot go beyond 5. So my upper bound is actually a 5. Now I ask you, if my S is there, S can be anything. Now, if my S has this character as 6, I am saying I cannot go beyond 5, and you are saying you want a 6. 5 is here, 6 is here. I am saying I cannot go beyond 5. You are saying you want a 6, which is impossible. So if this is the case, if this character, which means the S character at this index, if this, and again, if I am a tight, my upper bound, I will find what's my upper bound. If my upper bound is itself less than your value, let's say I will represent this value as A. If it is less than your value, it's always false. Return a 0. But bhaiya, if it is same, okay, if it is same, still it is a tight. It is same, it is a tight, which means I will have to check for the next value. But bhaiya, why next value can't simply say true? No. Why no? Because if it is actually a, see, if it was a tight, so you will simply go and ask for the next value, considering saying, okay, reducing the length. Now, okay, now the length will be only 1, and also saying, okay, it was a tight. This will be useful because as soon as, let's say you have a 4 here, right? Now I am saying this is a location, this is a S string, its last character is A. So now I am saying that this again can have multiple options. What if this A is a 5? This was a tight, so my upper bound is a 4, right? It's for tight, so I cannot go beyond 4. My S string last character is 5, which is more than it. For sure, return a false. But if it is a 4, last character is a 4 of S string, it is a 4 or a 3 or 2. For sure, if my upper bound is 4, which means I can have any upper bound saying, okay, I can try for lesser values for sure. So I can try for a 4, I can try for 3, 2, 1, 0. It's always possible to make these numbers. So for sure, if the values are less, simply return a true. So you will say that, okay, if you have only the last character left, then I will go and check the last character value of S. So that is a last character value of S, which is a suffix string which I have to match off. That is a A. That's A. I'm saying that digit is a A digit. If that is more than my upper bound, if this is more than my upper bound, simply return a false. Else, you can always make it simply return a 1, which is true. Okay, that was a case when you have a matching. But bhaiya, what if it is less? Oh, if it is less, oh, that's great. Then you can always make it possible. But bhaiya, how? See, if it is a less, which means your string, S string is, let's say, a 4. Here the character is a 4. Now next, any character whatsoever comes in. Let's say here comes in a 6 or a 5, or let's say any character. Let's say worst case, maximum can be 6. So let's say it comes a 6. Now I am saying right now I have a 5. So any way whatsoever, I can place any number less than 5 also. So I can place a 4, 3, 2, 1, 0. So for sure, for 4 I have the entire flexibility, 0 to 6, because 4 is not tight for me. So I have the entire flexibility. So I know that, okay, my maximum range is 54. 54 is the largest number which I can make. I cannot go beyond it, but I can always go less than it. And less than it, I can always make my number. I can always make my this digit. Right? This digit I can make. So always return a 1. Now, bhaiya, you can always make this particular suffix, but why you always return a 1? You want to make the multiple, you want to make all the substrings, right? Then how you know that below this number you will always have just one digit? Like you will always have just one number. How you know that part? Proceed. How I know this part is because below 54 you will only have a unique number s. Below 54 you will have only a unique number s, right? That's always the case. If you take a number, let's say 100, below 100, if I ask you how many number of 54s are there, just one, right? It's always, every number is a unique. That's the reason you will always have one number. So now we just recognize, okay, if it is a tight, then I will have three cases. First case is if it is more, your value at s is actually more, then it's false. If it is equal, then maybe I can try for a future value, which is I'll reduce the length and I'll say, okay, my tight continues. And then if it is actually a less, then for sure it's always true. So I can simply return a 1. But bhaiya, okay, right now here you consider it as a tight. But what if it is not tight? If it is actually, let's say it is not tight. So here my 4 made my next digit as tight, but let's say I place a 3. So for sure if it is a 3, so next digit it is not tight. If it would have been not tight, so I can place on any number from 0 to 9. But here I am bounded by a limit, so I'll place on every number from 0 to 6. So I for sure know that in this location I can place a 6, and for sure if it is not tight, so he will propagate not tight to the next value also. So here also I can place number from 0 to 6. 0 to 6, 0 to 6. That's it. 0 to 6, 0 to 6. It's a limit. And so no worries whatsoever. Whatsoever string s you have, you can always be able to make. Always be able to, because see, 66 is the maximum value which your string s can have. Bhaiya, how? Because s is only consisting of numeric digits which are less than, which are at most limit. So in the question itself it is saying that your s string is always bounded by limit itself. No worries on that part. So you know that you will always be able to make your numbers which are actually s. So simply return a 1. Writing the same condition out, if my n is less than equal to my s dot length. Now bhaiya, what this means? This means that let's say if it was your nums string, it was your s string. So s string is of 2 length. Nums string is of, let's say, 4 length. So as I represented, my num string will remain as it is, but to know that how much length is remaining, I will use a n. So I'm saying if my n is this portion. If my n becomes less than or equal to my s dot length, now I can start using my string. I can start comparing it with my s. So now I'll just say I'll start comparing it with my s. So how to compare that with my s? Simply, I had two conditions. If it is a tight, if it is not tight. If it is not tight, I saw that I will simply return a, oh, there's something happened. Okay. If it is not tight, I'll simply return a 1. Now, if it is a tight, I will have three conditions in this. As I told you, I'll have 3 conditions. First condition is that I will just figure out what is the character at that location. As we saw that I will find out the character at this location, which is a. It is a 6. Upper bound is a 5. So a is more than my upper bound. Simply return a false. A is more than my upper bound. Simply return a false. Bhaiya, what if a is equal to my upper bound? Okay, a is equal to my upper bound, then simply try on for a lesser length, and okay, it is a tight. Okay, I'll try for lesser length and minus 1, and then okay, a tight. That's it. Bhaiya, what if it is my a is actually less than my upper bound? Oh, no worries, then it's always a true. A is less, then it's always a true. Return 1. So it's a true, return 1. That is how you will handle this case, right? When your string, when your suffix part will actually have to match. Basically like you are at this portion of the suffix of your nums where you are matching your suffix part. So that is the only thing which you have to do. Make sure that you are handling your suffix. Make sure that you are handling your tight. That okay, if you have a tight, then you handle this portion. This is the exact same portion here written itself, right? And ultimately, this was the portion for the part which is not in the suffix, which you have luxury to do anything of. As I showed you, the previous part which I showed you, the part right here which I showed you is the part of code which I will need to match. Let's say here is my s, here is my actually nums string. So this below portion, this portion you will have to match when you are actually at this portion of the string. For the remaining starting portion, you can simply apply your digit dp, which means going on for all the past possible values of nums, which means from digit as 0 to the upper bound, but upper bound is always also bounded by your limit, so upper bound or limit. So code is also exactly same. Firstly, as I showed you, that to get the answer from start to finish, right, I will go and get the answer, okay, from 1 to finish, and I'll also go and get the answer from 1 to start minus 1, and then I can subtract these values. So here, as you can see, this value is represented by a, this is by b, so I'll do a minus b. As you can see, that is done here itself, a minus b. Now to find your a value, it will be same, just a b value. It will be like function called are actually same, solve function. It's just that here you can see I am passing a r is converting your finish to a string. Here I convert my start minus 1 to a string L and then pass on to the next function, which is this b. As you can see, b. So the only change is actually this r and this one. So this is a string which I will pass on. This is for tight, and this is the length which I will be changing in my function n, in my function solve. I will be changing this particular n itself. Now let's come on to the function which is solve. It will be exactly same as what I showed you also. I will have a solve. This string will remain constant. I will have my tight. I will have my n. That's the only two things which will change entirely, right? This, everything else constant. That's it. Now firstly, a very basic, as I showed you, that if my length itself of nums is less than my suffix length which I wanted, so it's always impossible. Return a 0. Memoization case, simple memoizing, because it's a simple recursion, and its problem name is added a digit dp, so for sure you will just simply memoize that. Now you will go and find the upper bound, as you saw. Okay, if it is tight, then go and access the element from your nums, else go and find the limit itself. Although if it would have not been limit, so I would have done 9 here, but it's a limit, so you have bounded by the limit itself. Okay, great. Now you will get the simple case as I showed you. If you have just one element remaining, it is exactly same thing which we saw here also. If you have just one element remaining, then you will compare like this. Remember that if you were just comparing, that if you have just one element remaining, then you will compare like this. Exact same code written down below, that if you have one element remaining, then you compare like this. If not, then if I'm comparing my suffix portion, then I'll use this piece of code. If I'm comparing my suffix portion, I'll use this piece of code. That's it. Exactly same code which I showed you here also. If I'm comparing my suffix piece of code. And then ultimately, if not, I'm comparing the starting part of code, not the suffix part, then I can try for all the possibilities from 0 to the less than equal to my upper bound. And that's how I can simply try on for all the possibilities, considering I will have to propagate my correct tight and also reduce my n. And these are the only things which I'll change. Rest all will remain constants. Again, here you will pass this everything by address. Although it will not give much difference in complexity, because every length is 15, in worst case 15. So that will not impact much your time. But still, ultimately, you will simply return your dp of n, tight. Now, the time complexity of this is log n into 2. Bhaiya, how? As you saw that you are using your n, you were using this n, right? You were using this n. As I showed you, you are using this n. Now this n is nothing but the length. This is the length of the string. Your length of the string is what? 15. As you saw, the length of your string, if you go back, look at the constraints, constraints, yeah. Your string length is at max 15 because it's a number, it is 1e15. 115 is just 16 digits at max. So I know that I will have 16 digits at max. So in worst case, that will be log n to the base 10, right? I will have 16 digits. So considering that n is actually my number 115, so I'll say that number of digits in the string can be 1e10. Sorry, it can be at max 16. So I know that, okay, my start and finish is less than 115, so I have at max 16 digits. My type date can be either 0 or 1, and then ultimately you saw that I was iterating on a for loop, going and trying for all the digits up till the upper bound. So the upper bound is itself at max 9, so I'll use a 10 for that, 0 to 9. So that will be your time complexity, and that's roughly constant if you just focus on that. And the space is also same, which is 15 into 2. Again, it is roughly constant. So this is the most, again you will find the binary search solution and all that stuff, but most intuitive is the digit DP itself. All the people will say you can simply solve it by binary search and all that stuff, but digit DP is the most intuitional form, and we should go, and again you can go and look for the many top coders solution. You will see that every one of them have done in digit DP, but still you will find solution using binary search in the LeetCodeDiscuss page. It's just that people think of digit DP as a hard concept, but if you had been with us, then it would have been amazing. Cool. Thank you so much for watching. See you guys in the next video. Until then, goodbye, take care, bye.